Hello everyone, we're the LIBRA project. I'm Miriam.
I'm Friedrich.
I'm Siobhan.
I'm Nick.
So getting started, this project was created just because a lot of aircraft accidents are caused from stall, and we want to create a potential solution to reduce this and increase controllability during stall for the pilots. And so it was created to show the augmented rolling mechanism using the lead bracket, and it will ideally allow better control during stall, especially with banks. So part of our objective is to create multiple models with different wing shapes and even winglets later on over the year, and so we will also be testing these and comparing the data. We are finding 4 forces, the rolling and pitching moment, as well as the lift and drag, and so being able to compare these forces.
For our design requirements, our planes need to be modeled so that they're able to hold 2 servo motors to control each of the driving mechanisms. The ailerons will be held out of phase, and the elevators will move in phase. In order to accomplish our plane assembly, we'll be able to 3D print the models and then put them together. For our team structure, all of us in the project report immediately to our graduate advisor, and each subsystem is broken down into project manager and then mechanical and electrical teams.
Okay, so for the mechanical side of the project, our goal is just to completely fabricate all 5 plane models, which you can see here. All the names are based off of their wing shapes. As for electrical, we basically had to create a load cell to measure all the forces on each plane for testing. So we had to calibrate it, and those, as well as the servo motors inside the planes that were driving the ailerons and the elevators had to be tested as well.
Here we have our 4-axis load cell, and so like I said earlier, this will be used to measure 4 forces on the plane. It consists of 5 load cells shown here, constructed all together, and so the whole point of the system is to be able to collect the data that we need. And this has been a continual process, working on it throughout the quarter for the electrical team.
Okay, so the main difference in our models was the wing shape. We have 5 different wing shapes. Those would be rectangular, trapezoidal, crop delta, elliptic, and rectangular trapezoidal. And the main assembly differences that these caused were the wing shape, of course, because they are different sizes. They caused differences in the fuselage, so that was our main difference in the assembly. And so these 2 here are our delta and elliptical models, and as you can see, the wing planform shapes are very different. And then our other 3 models are rectangular, trapezoidal, and trapezoidal. And the differences for all of these are the angles at which the wing protrudes from the fuselage. So rectangular, of course, is perfectly straight, while trapezoidal and rectangular trapezoidal have some angle. Our timeline for the year, so for the fall quarter, we aim to complete the assembly of all 5 models, as well as the driving mechanisms, as well as calibrating the multi-axis load cell. In the winter, we're going to start testing our models in the wind tunnel. So we will be finding our lift, drag, and rolling moment from that. And we also plan to assemble the winglet models. And in the spring quarter, we're going to continue testing the models in the wind tunnel, as well as analyzing and comparing the force data that we obtain.
As for what progress we have done, we have the delta, trapezoidal, and most of the elliptic models completely assembled and painted over. And those 3 models also have the internal mechanisms installed. We just need to finish testing all of that. And the primary constraint was the 3D printers that we were using for assembly, because for one, a lot of the parts took a long time to print, and we went through some technical difficulties with it throughout the quarter. As for electrical, we did finish calibrating the load cells, and all of the programming that was required to use LabVIEW has also been finished and successful. So for the rest of the quarter, we're just going to continue trying to reach our original goal, which is to have all 5 plane models finished, which would be rectangular and rectangular trapezoidal. And again, we're also going to finish testing all of the internal mechanisms in the planes, including the servo motors and the degree of rotation. Thank you for listening to our presentation.